My name is Ziyong and I'll be doing advanced static analysis on our chosen malware. So to start off, I'll be showing you the overall graph of all the function calls. So as you can see, these are a lot of function calls. So I will only be explaining those subroutines that I think are very important for the malware to function. Okay, so let's move on. Okay, so for this very first subroutine 4436F4, you can see it's very long. I would like to bring attention to the first function call get computer name A. So this function captures the net BIOS name of a local computer. In our case, it will be web code, which I'll be showing here. Yeah, this is web code. It requires the N size and LP buffer parameter, which is being pushed in over here and here for this function call to operate. Next function call that is being called is the get username function. Basically, this function retrieves the username, which in our case is Patrice. And for the very last function call for this subroutine, it will be get logical drive strings A. This function call fills a buffer with strings that specify valid drives in the system. The buffer size, as you can see, is being pushed in, which happens to be 32H. So if the buffer size is not large enough to fill the strings, the size required will be returned instead. According to the assembly code move EDX offset blah blah. Okay, this is in Spanish, so it translates to units available. So apparently the malware author wants to know how many drives are available in the target victim. So from this very first subroutine, I can tell that the malware author is trying to do reconnaissance and try to gather information about the victim. The next subroutine that we will analyze will be 40734. Okay, so we'll just jump to the address 40734. Okay, so for this subroutine, as you can see, it calls another subroutine. Over here, it tests EAX if EAX. This is to check if EAX is empty. So if EAX is empty, the 0 flag will be set and it will jump to location 403D56. Else, it will return to the subroutine where the program will continue. So over here, when it continues, it will call the function delete file. This function basically deletes the file as the name suggests. And the required parameter to be pushed in is LP file name, which happens to be EAX, which was also tested in this subroutine. So from here I can infer that the malware author is trying to delete certain files from the victim system. So moving on, we analyze subroutine 440354. So this is a really long subroutine. Okay, so basically over here there's a test operation with this variable 10H. So jump not 0 location 440640, meaning it will jump to this location if the 0 flag is not set. Okay, so it will go down here all the way here, and basically this just marks the end of the subroutine. So what if the 0 flag is set? Okay, if the 0 flag is set, there will actually be a function call called WSA startup. So what this function call does is that it initiates the use of winsock.dll, which provides a common API for the use of TCP IP stack. There is two parameters which is being pushed in, which is EX and 101H in the form of LPWSA data and W version requested. So these two are the required parameters for WSA startup to operate. So after this, the Windows socket will be initiated. Further down, there will be another function called socket. Basically, what socket does is allows the memory author to transmit data across the wire. So it takes three parameters, 6, 1, and 2, which represents protocol, type, and AF. These three are the required parameters for the socket to run. So basically, what the 6 means for this is communicating through TCP. 1 also means TCP, while 2 means that it's using the IPv4 family address. Moving on, there will be this function called WSA sync select. Basically, this requires the Windows socket to generate a notification whenever it detects an event specified by the iEvent parameter. The required parameters are S, HWND, WMSG, and iEvent. So they are being pushed in for the function to operate. Lastly, the function called WSA cleanup will be called when the 0 flag is set for this compare. So if the 0 flag is set, you initiate WSA cleanup. WSA cleanup basically closes the Windows socket. So this closes the whole session that was created above. The next subroutine that we'll be analyzing is 43C634. Okay, so for this subroutine, we start out with a compare EAX with 100H. So if 100 is smaller, the program will go to 43C6C0 over here. So basically this marks the end of the subroutine. However, if 100 is larger, the program will continue over here. Okay, so after that it will compare another time, but this time with 108. Same thing, differently. If 108 is above EX, the program will go to 43C6C0, which is down there again. It marks the end of the subroutine. Conversely, if 108 is smaller, the get captured function will be called over here. So basically what get capture function does is that it retrieves a handle of the window that has most activity, which basically means that the window that is with the recently most active. So after that, it tests ESI with ESI. Okay, and then if the 0 flag is not set, you will go to 43C691, which is this, where the get window long function is called. This basically retrieves info about the specified window, which is the window that was captured here. After that, EAX is compared with EDX, and if the 0 flag is not set, it will go to the end of the program in location 433C6C0. If the 0 flag is set, it will move, the program will continue, and the send message A function will be called. So what this function does is that it will send a message that is specified by the malware author to the window. So it requires 4 parameters: H, WND, MSG, W param, L param. So the message to be sent will be specified in the MSG parameter. After this, it will end after the test EAX with EAX, and the 0 flag is set. The last subroutine that I will be analyzing is 43B 57B. Okay, so for this subroutine, HHK is being compared with 0. If the 0 flag is set, it will jump to location 43B 58C, which is over here. But if it's not set, the value in HHK will move to AX, and it will be pushed into the unhook Windows hookX function. So what this function does is that it will remove a hook procedure, and the hook procedure is actually established in the iData section. So what a hook does is that it will monitor the system. After this, it will go to location 43B 58C, where EAX will be XORed with EAX. This is to clear the EAX register. EAX will then move to HHK to clear the HHK variable. After which, there will be a compare dword 4467E8 with 0. If the 0 flag is set, it will move to location 43B 5D3, which is here. So basically this just marks the end of the subroutine. If not, you will call the function setEvent and get current thread ID. I will not explain this function because it's not very relevant. After which, there will be a another compare function. So if the 0 flag is set, you will move to location 43B 5C1, which is here. If not, the function wait for single object will be called. So this function basically returns a value when a specified object is in the signal state, or when the time runs out. So the time stipulated will be this value, and it will be pushed inside. So if the time runs out, it will return what went wrong in the function instead. After which, the handle will be closed in this function. So yeah, that marks the end of the analysis. So from this advanced static analysis, there's a possibility that this as it tries to gather the user information like the computer name and the username as well as the drive available. It also tries to delete files from a user system. Not only that, it tries to establish a connection using a socket to the malware author. With this socket, the malware author has a chance that it will be able to transmit data either from the malware author's computer to the victim, or for the victim to the malware computer. And it's also able to spy on the victim's active browser and try to gather information on what it's trying to do. So this backdoor is highly malicious as it tries to gain valuable information about the victim.